This is the electronics show. We do this every time we teach the electronics class. I have a class this year of about 13 students, and they're doing 6 different projects. They pick something that's interesting but challenging, and it involves electronics of various different types, analog electronics, digital electronics, and they do some programming. And it all boils down to real-life engineering, trying to solve problems, get things to work, and succeed at some goal that they've set for themselves. So that's what they're all doing today.
All right, well, this is our safety cart, and the idea is that you can steer the cart based on where you move your nose, so you can turn your head and steer the cart from left to right, as you see John is doing right now. You'll see in front of John that there's this little camera that picks up the coordinates of where his nose is relative to the camera.
The laser draw-in is a laser art interactive interface where users can stick their hands in 2 little boxes that are filled with light, and they control where a laser goes, and they can draw images and manipulate those with their hands.
So these are the Robocops. We have 3 cops and 1 robber, and the 3 cops are trying to catch the robber. They're doing all this staying on the black lines. They have some sensors in the front, so they're trying to keep the 2 middle sensors on the lines but looking for intersections. They can tell the difference between cops and robbers. They all emit infrared frequencies, and they emit at a different frequency. So the cops have a certain signal and the robbers have another signal. So they detect that, and once the cops find the robber, they try to turn towards it until they get close enough, and then they'll stop and catch the robber.
It's just a robot which we built on a chassis of just a regular toy car. And what we did is we hooked up a circuit and added these rangefinders, which are supposed to detect the distance that objects are within the robot, and therefore they send the signal. The pololu tells it whether to turn left or right or go backwards, depending on where the object is at.
This is the scooter, and the idea is a self-riding, self-balancing scooter. And so we got a kid's toy, an electric scooter from Walmart. We took it apart and got the speed to be adjustable, and then we put a couple of sensors on there to let it know about the world around it. And so the 2 things it knows is how far it's tilted over and how fast it's falling. And it takes those numbers into this PIC chip, and we do some calculations with those and send them to the servo motor here, which steers it.
This is the Navigon 5000 LT. It is our GPS-guided robot. It has a GPS unit and a compass unit. The GPS unit is good maybe plus or minus 13 feet. So what we do is we give it a target point of latitude and longitude, take it somewhere else, let the latitude and longitude settle, use that second point to calculate an angle from north, and then use the compass to determine if we're facing the right direction.
Doing that project, getting through and meeting that challenge serves them well to become good scientists and engineers, especially to pass those challenges.